On the 12th of November 2014, the world watched as the Rosetta mission team attempted something breathtakingly audacious. Philae was about to make history by performing the first ever controlled landing on a comet. The lander sent back the first ever images from the surface of a comet and undertook 60 hours of science. Philae then went into hibernation, and apart from several brief periods of contact last summer, since July the 9th the lander has been silent. Philae's legacy is enormous.
It gave us the ground truth. It gave us really the data from the surface itself. Physical properties, also chemical properties with the mass spectrometers. Also it allowed the radar measurements. So if you embed it into the overall Rosetta data and results we have, it has revolutionized our understanding of comets, and in some sense also our understanding of the history of the solar system, and it gave us new input for understanding the origin of life.
It wasn't all plain sailing. The harpoons didn't fire on landing. As Philae wasn't anchored, it bounced across the surface of the comet. When the lander finally rested, its position meant Philae couldn't drill into the soil to collect samples for the different instruments. Instead, they went into sniffing mode, analysing the gases surrounding the comet and from scattered dust grains. 80% of its planned science was completed, with measurements from multiple landings across several locations providing unexpected benefits.
This kind of investigation, comparing measurements in particular of the magnetic field of the nucleus and of the tensile strength of the surface, would not have been possible if Philae would have conducted its operation exactly as planned. So in a sense, this rebound was an opportunity for investigation that were not, which we had not even thought about.
By working with the orbiter, Philae helped scientists understand how the comet's interior is formed. Radio waves were transmitted between the lander and the orbiter to see how they were reflected and transmitted through the comet's nucleus. And the small lobe, the head of the duck-shaped comet where Philae rests, was found to be fairly homogeneous. This sort of information, especially knowing how hard the surface is crucial for any future missions which may involve a sample return.
For me, the Philae mission has been a great success, not only because it was a first landing on a comet in 2014, but also because it has acquired great scientific data, which are now published in various scientific papers. So the success of Philae is already there, and it will be for posterity.
Philae has always been the cherry on the cake in this mission. The main aim was to map and monitor the changes of a comet as it approached the Sun, reached its closest point and greatest activity at perihelion, and then follow the comet as it moves away from the Sun, including flying through the comet's tails. This crucial work is being done by the orbiter. But even children have been captivated by the lander through the cartoon activities of a tiny robot on a small comet far away from home. The orbiter continues its work until the end of its mission in September, when Rosetta will join its lander on its final resting place. The plan is to send the orbiter directly onto the comet, with its instruments collecting the last pieces of scientific data from Comet 67P Churyumov-Gerasimenko.